So these are all the elements of the collision system. So in the collidable header, I have the pointers to the registration commands, as well as the registration state to prevent duplicates, and also a reference to the fast deletion during registration and the registration. And I also have the private functions, the scene registration and the scene deregistration, as well as a pointer to a model, and also a collision volume sphere, which is the bounding sphere that we're using to detect the collision. And the collision volume sphere, it's pretty simple. It derives from the collision volume parent class, and the data it only has the center, the radius, the matrix, and also a visualizer pointer command. And on the public side, it has a user accessible functions, the compute data, which will update the collision volume sphere in world space, and then the intersect function, which is an operation in the meantime, which has the collision volume base class, and the intersect function that actually takes a bound sphere, and then getter functions to get the center of the bound sphere as well as the radius, and also the get command function. And on the collision volume B sphere, it's pretty simple, just getting the difference of the both center of the bounding sphere and then the magnitude of that vector. If it's less than the addition of the radius, then they'll intersect. So I have this exime function in the BE in the Vultr Engine math tools. So this is pretty much what the collision volume B sphere does. Then going back, I have the protected function set collidable group that will it will assign a particular ID to a specific collidable type. And then I have also other user functions such as the submit collision registration and the registration, as well as the set collider model, and also the update collision data. And on the public side, I have the callbacks for the collision, otherwise the dispatch will not work. And I also have a get sphere function, which is constant, that will return the collidables B-sphere. Then the registration process, it prevents duplicates using the registration state, and it's also using the command pattern. And I have a collidable attorney that only guarantees the access to the registration and the registration of the scene only to the commands. And in the collision manager, so this is the collision manager. So it has a vector of collidable group pointers and also a list of the collision tests from command base. So this is what the commands look like for both the pair and the self-test, both inherit from the collision test command base class. And the collision test pair have 2 pointers for each of the collidable groups, while the test self command it only has 1 pointer. Then the commands also have a pointer to the collision dispatch, which is obviously private. And then on the public side, I only have the execute command function. And this is the collision dispatch. So the collision dispatch inherits from the collision dispatch base class, which is an abstract class with only the process callbacks function. And what the collision dispatch does, it'll just process the correct callback by doing a static cast of the initial type of the collidable, and then assuming the collidable has the collision function, it'll just it'll do the callback with the corresponding collidable that it's currently colliding with. Then going back to the manager, it also has the set group for ID function, which will set up an ID for a particular collidable, and then the process collisions, which is also private. And this one is only accessible to the scene through the collision manager attorney. And then I just have the get type ID. It returns the type ID for the particular imputable, and it also I have the functions set collision pair as well as the set collision self test, and also the get collidable group, which returns the collidable group based on the ID of the collidable. What the set collision test pair and the set collision self function do is just set up the correct collidable group for each of the object, and then it'll just place it into the correct dispatch, and then the dispatch and the collidable groups are going to send to the collision test pair command. And similarly in the collision test self, except that we're only using a single collidable group, and then we're just passing it through the collision test self, and therefore the collision test pair command, when it executes, it will iterate through both of the lists and compare each other collidable, and it will just call the math tool functions on the intersect to check if both of the bounded sphere for each of the collidable intersect, and then if they intersect, they'll just process the callback through the dispatch. And the collision test self is pretty similar. I have the outer loop to start from the beginning of the collidable group, and then the inner loop it'll start at the end of the collidable group, and then it'll just break when both of the iterators reach each other. So that guarantees that the collidables are not doing a self test check, and also that all the collidables from the list it will check just once against each other. And this is pretty much how the collision system diagram looks like. So it's hard to see from this distance, but on this side, this is particularly for collision registration, while this side is for collision setup in the scene. So let's start with the setup. I'm not going too much into detail. So for the setup, it starts in the scene calling the set collision pair. Then it will call the collision manager, and it'll just create the correct collidable group and also the correct collision dispatch. And then the commands hold a reference to the collidable group as well as the dispatch. In this case, the collision test pair holds two different collidable groups, while the collision test self it only holds one. Then when the setup when the collision is set up correctly, the relationship between the frigate and another game object, then we proceed to register the frigate into the actual scene, which the frigate inherits from the game object that inherits from the collidable, and then the collidable has the pointer of the commands to the registration, and then they'll be sent to the scene attorney. And that's pretty much the same with all the exables. But the collidable here, it also has a pointer to a B-sphere, and this is pretty much what the collision volume B-sphere looks like. So it derives from the collision volume, and it has the setters and getters, as well as the intersect function, and the center and the radius data, as well as a pointer to the visualizer command. And the collidable also holds a reference to the model of the frigate. And this is pretty much how the collision system works. So this is how the documentation of the collision system looks like. So it's separated into different sections, the collision setup, in which I'm highlighting the setCollider model function, the update collision data, the collision callback, the compute data within the collision volume, as well as the get center from the collision volume B-sphere, as well as the get radius. And I have some example code on how to do the proper callback, or also some details on the function of the compute data. And that's basically the setup. And for the registration, I have the setCollidable group, as well as the submit, the user function, the submit collision registration and the registration, as well as the functions for set collision pair and the set collision test self. Since this one is a bit more complicated, I have a registration process all the way from the scene until it reaches the callback for each of the game objects. And then I have a more detailed description of each of the functions. And this is pretty much how the collision documentation looks like.